A beginning is a very delicate time. Know then that it is the year 2024. The known macOS world is ruled by the Padishah Emperor Tim Cook I, our leader. In this time, the most precious substance in the universe is the banana. The banana extends life. The banana expands consciousness. The banana is vital to MSA. The monkey tribe and its navigators, who the banana has mutated over 4,000 years, use the banana seeds, which gives them the ability to live, that is, not dying. Oh yes, I forgot to tell you. The banana exists in only one city in the entire universe. A rainy, windy city with vast oceans. Hidden away within the buildings of the streets are the people known as Max sysadmins, who have long heard of prophecy that a new snow leopard would come, a final version which would lead them to true freedom. The city is Gothenburg, also known as Göteborg. Thank you. I think I'm at the peak of my presentation, so probably we couldn't hear. So thanks again. My name is Csaba Ficl, and I'm really glad being here again. I really love this conference, and I plan to talk about some disk arbitration vulnerabilities and their history. Currently, I'm working at Kanji as a macOS principal security researcher, which means I'm doing offensive research almost full-time and some advising as well. I used to be the author of the macOS exploitation training for OffSec. I do macOS bug hunting, almost 100 CVs. Shortly, I used to be a red blue teamer. Before I'm married, have 2 kids. I really love running. I'm actually doing my multi-year project of completing the Götaleden Trail near Göteborg. So the agenda for today, I will talk about the service, the disk arbitration service first, and then about 4 CVs. One of them is removed, thanks to Apple. I will rant a bit more about it when we get there. So the disk arbitration service, what is it? It's a system-wide service defined in the COM Apple disk arbitration D plist. It's the disk arbitration daemon, in short. It offers a mock service under the name COM Apple disk arbitration D. Actually, it's a mock service. It's not XPC. It's still a classic Mac service written in MIG, the mock interface generator. And basically, this service is managing disk mounting, unmounting. You can talk to this framework. You can create callbacks. So whenever someone tries to mount something, you can get that callback, and you can authorize the mounting, and so on. So that's the basic idea. Why we like it as security people? First, it runs as root, so it's pretty privileged at first hand. It's unsandboxed, so you can potentially use it for sandbox escape, and not just potentially. We will see later today that practically you could use it for that in the past. It also has full disk access rights, kinda. If we check the entitlement of this binary, we can see this COM Apple private security storage exempt heritable, which is basically full disk access or behaves like full disk access. The important item is that it has the heritable word, which means that when disk arbitration calls another process, and under the hood it will call the actual mount binary or the unmount binary, that process will inherit this privilege. So the mount binary will run with full disk access privileges as well. And it's open source. So we can actually download it from Apple and audit the source code. So this is like a magic combo. It's super privileged. Oh, you can access it from the sandbox. So if you have a sandbox application, you can actually talk to this service. So it's accessible, privileged, even for TCC. You can easily audit the source code, so perfect. And again, it has the MIG service. They define quite a few routines. We don't even need to deal with these routines directly because there is the disk arbitration public framework, which you can use to interact with the daemon. And that framework will call the routines for you. So this is the basic call flow of diskarbitrationd. You don't need to deal with this, but this is what happens when you start a conversation with diskarbitrationd. That, let's say, in our example here, I want to mount a device under a certain folder. We arrive into the diskarbitrationd on this DA server session queue request. This is the main handler function which receives all requests, not just mount, but unmount, rename. Now with Sequoia, they have 2 or 3 new operations they can handle. And this is the most important function in the entire flow. All of the authorization checks, the sandbox check, the privilege checks, everything happens at this stage. If we pass this, we are good. It will also call out to DA authorize for authorization, but in my experience, everyone is just authorized, at least if you are like a regular admin user. So that will call out and queue the request inside. That will call request dispatch. That will call to request mount. Now that function will make a call out to the DA mount contains arguments, and we'll specifically check if we want to mount a snapshot, like an APFS snapshot. And it specifically disallows mounting snapshots inside. And it happens at this stage. Then it goes on, and at the DA mount with arguments, it basically starts to construct the mount command for you. Because when we called diskarbitrationd, we said that I want to mount this device to this directory with these options, which are like integers. But the actual service has to construct the mount command that it will execute. So it basically makes a translation. And eventually, we get to the DA command execute, which will call POSIX spawn, and will spawn the mount command. So before we go into the actual vulnerabilities, I want to review how the basic mount call works in terms of privileges without the diskarbitrationd service. We will see a bunch of similar call flows I'm showing here, and they will just get more and more and more complicated. So this is the base case. We have the caller, which is us, running with some privileges. We have the mount command, and which will call into the kernel through the mount system call. I'm not showing the mount APFS and all these others. It's like that one box. So if we call the mount command, it will run with exactly the same privileges as us, including the sandbox restrictions, everything. And then it will call into the kernel. And the kernel will check, does the caller have permissions to mount over this directory? Like, I'm Chaba, I'm not allowed to mount over a directory which is owned by root. Or it will also do the mandatory access control framework callout, which is basically, there are many kernel extensions like the sandbox that hooks all of these system calls and will perform extra checks. So for example, this will ensure that I cannot mount over like a system integrity protection protected location, like a zip protected location like library Apple, for example. So let's just play through one simple flow. As a user, we want to mount over a directory which is owned by root, and the disk owner is root. I'm listing the disk owner every time because that will be really important later on. We call mount, same privileges, nothing changed. We get to the kernel, it says, no, you can't do that because you have no rights for this. So the first vulnerability from 2017, this is not my finding. It was a finding in the Pwn2Own hacker competition and was one of the vulnerability in the whole macOS exploit chain. They used this for privilege escalation. It was found by the Phoenix team, Niklas Baumstark and Samuel Gross, and they have a very detailed write-up about the vulnerability. But in short, what it is. So again, we have the service. We have this very important function I told you about, and this is where all these checks are happening. It will check if the mount point exists, and if yes, then it will check if the mount point where we want to mount our disk is owned by the same user who is making the request. This is basically try to rule out that I cannot mount over a directory which is owned by someone else like root. And if that fails, it will return. Now, and then done. If we pass this check, then there are no further checks. And we will have a time of check and time of use bug here, because if you remember that long call graph, this is happening at the very beginning, and the actual mount call happens at the very end. And between those, we can simply swap the target. So if I specify like a symbolic link as a target, which points to a directory, we can use it to pass the check, swap the symlink, and when we get to the end, then the new location will be used. So let's just use our call flow again, but now with having diskarbitrationd in the middle, who runs as root and unsandboxed. Now, and I listed what it does check. It will check the user ID if it's the same as the mount point owner. So we start as the user, and we say diskarbitrationd, hey, we want to mount on this symlink, which is pointing to temp MNT, which is owned by us. And I want to mount a disk which is owned by the root user, like the EFI partition or maybe another volume on the disk. It will say, yeah, pass, you are good. You want to mount over a directory which you own, you are the user, go ahead. I will make a request to mount. At this stage, I swap the symlink. The symlink now points to var at tabs, which is where you store the cron tab files. And if I go back, the disk owner was root. And what diskarbitrationd does, it will make the call, the mount call, with the ownership of the disk. So that's why the mount call will run as root, because the disk owner was root. Now the symlink is swapped. The target is also owned by root. And again, the disk owner is still root. We get to the kernel. It also says pass. You are root. You are free to mount over this directory. And boom, at this point, we have a privilege escalation because we can mount the disk over the var at tabs directory and drop a new cron job as root, and that will be executed as root. So here's a video showing this. This is not my exploit. This is what was actually used in the competition. So it's a race condition, so you need to swap the links. So it's not like an instant thing, but it's still pretty fast, and you can enjoy some high Sierra vibes from the past till it's running. Yeah, it's done, and it went to root. So how Apple fixed this? I think to date, at least from the fixes I saw, I find this one of the most brilliant fixes ever done by Apple. They did a very, very simple thing in the privilege check. They don't check if the target is owned by you. They check if the disk owner is the same as the caller. This, for first, it didn't make sense to me. But because the disk arbitration D does the call as the disk owner, basically it ensures that whoever is calling into disk arbitration D will be the same caller who is doing the mount call eventually. Let's see why this fixes the problem. And I will go through two case scenarios because I think it's not trivial to understand why this works. But this works and it makes a lot of headache for me. So again, we have the same setup, but now we have another check. So let's say we are the user. We want to mount over a directory which is owned by root, and the disk owner is root. We get to disk arbitration D, and it says, no, the disk owner is different. You are not allowed to do it, so it will fail. Okay, let's try another one. Let's try a DMG, open a DMG, and let's try to mount that one. The DMG will be owned by us. Disk arbitration D will says, okay, you are good to go. You got a pass. The disk owner is the user, so the mount command will be run as the user. And when we get to the kernel, at that point, we will get a fail because the kernel will do the privilege verification for the target, and because the target is higher privileged, we cannot mount over the directory. So yeah, it solves the issue. Okay, a sandbox escape. This is almost the same story as the previous one, but with the sandbox. We have the same important function again, the DA server session queue request. That's where the sandbox check is happening. It has to happen because if you remember, disk arbitration D is not sandboxed. So if it wouldn't check it, if the process is allowed to mount on that location, it would mean that it passes the operation to the kernel. The kernel does perform a sandbox check, but it will do the check on the calling process, which is mount, which runs unsandboxed because disk arbitration D called it. So the kernel will not see us. That's why disk arbitration D has to do this verification. I have listed the two source code, the old and the new one, like the old bug and the new one. We can see that there is a pass resolution happening, check for a pass. Again, the left one is where it check the privileges, and the right one where it check the sandbox. And yeah, it does a privilege check, sandbox check. Same story, same time of check, time of use bug, because from this point, no verification happening. But I was like, this is, okay, this looks great, but I want to verify it. I'm not developing an exploit straight because winning race conditions can be really hard. You can either be too fast or too slow. Yes, you can be too fast sometimes. So I usually used to like attach a debugger to the process and stop it at certain points so I can ensure that I actually win the race there. And if I can verify there, then I can try to write an exploit for it. So I created a sandbox profile, which didn't allow me to mount over the temp disk directory. Started the shell with that profile, tried it. Okay, the sandbox profile works. That's the first step to verify, because I can also screw up the profile. So next step, I will start a mount over the temp disk. No, first I will set a breakpoint on the sandbox check function on diskarbitrationd. Then I'm starting a mount over the temp disk2 directory, which should be allowed. I hit a breakpoint, I do finish, which is completing the sandbox check. It returns with 0, which means you are good to go, you passed the check. And at that point, I delete the disk2 directory, place a symbolic link pointing to disk, which again I'm not allowed to mount over, continue the disk arbitration process, and at the end I could mount over the disk directory. Okay, so this works. So I know that okay, the vulnerability is there and there is a problem. But how? Okay, here's the flow chart again. Sorry, again, so this is the idea. I have the link pointing somewhere. Again, we get a pass from diskarbitrationd. We swap the link somewhere outside the sandbox. We will talk about it where exactly. And the kernel will allow it as well. Okay, so how do I actually exploit it? So I know I can mess with the symlinks again, but how do I effectively get code execution outside the sandbox? How do I weaponize this? So first of all, what I can mount and where? It wasn't easy to answer. So what I can mount, in Pontoon they use the EFI partition, which is specifically disallowed in the diskarbitrationd, so that's not working. I was like, okay, I will mount a DMG. But a DMG is not a disk, and like it's a disk image, but diskarbitrationd works with dev devices, not with DMG images. I need to get a dev device from the DMG image. And that is done by the disk management daemon and the disk helpers, I think. And those are not reachable from the sandbox. I cannot call into disk management that, hey, I have a DMG, please make a dev device for me. It wouldn't work. And then I realized that, okay, I can drop a DMG and I just can run the system command open whatever DMG. And macOS will be nice enough to actually open the DMG, create a dev device, mount it, and you get this finder pop-up. So that's great. Now I have a dev device, although I have it mounted, which I didn't want, because I want to mount it somewhere else, but at least now I have a dev device. Now luckily, I can call unmount on it through the diskarbitrationd service, and there are no checks on unmount, by the way. So you can call unmount and it will always run. No verification at all. Like there is an authorization, but it usually always works, so you can do unmount. So where do we mount? Probably there are many answers to this. I picked the preferences directory because inside the terminal preferences settings, you can set a shell command which is run when you open terminal. So I set whatever shell command I want. I open terminal and that will be executed. And because terminal is outside the sandbox, I executed something outside the sandbox. So this is how I escaped the sandbox, basically. So just to sum up, I drop a DMG, call open, I have the dev device, I unmount the directory, but I still have the dev device. I start to swap and race the symbolic links, and I will call into to the diskarbitrationd service to try to mount over those symlinks and hope to win the race conditions. And when it was successful, I just opened terminal. So this is the terminal preferences. So I'm just showing that there is nothing set there, and that the application will launch is sandbox. So it has the COM Apple Security App Sandbox entitlement, which means it's sandboxed. So I just start the application. Yeah, it doesn't log any output, but so it dropped the DMG, so we can see that it was opened. Now it's unmounted, and this was a much faster race to win. And we can see that it's mounted over library preferences. And if I open the preferences, we can see that the command is set there. Fix, also very clever from Apple. They added a forced option into the mount command with the -k option, which means don't follow symbolic links on the mount point. And it's not just the last item, but anywhere in the path. And it's forced. So it doesn't matter if you set it or not, it will be always set. And actually, again, the decision is pushed down to the kernel, which is pretty clever at this stage. Another sandbox escape. This is the screenshot from the previous video. This is like the very end of the video where I mounted over library preferences. What's the problem here? I didn't notice for a year. I will not wait that much, but if anyone has any idea what's missing from there, there is no quarantine flag. Why it's important? If I'm so the quarantine flag is basically telling the system that, hey, you have to run a very deep gatekeeper check, X-protect, and it just keeps increasing nowadays. So basically, if you drop a quarantine something and try to run it, if it's an application, then at minimum, you will get a pop-up that, hey, do you want to allow this, even if it's notarized and everything. Now, if there is no quarantine flag, nowadays there will be still a gatekeeper check run for it, but in a limited fashion. And if it's not like malware and it's properly signed, it will just let it run. So why it's important to have the quarantine flag? Because if I'm in the sandbox, and if the quarantine flag wouldn't be set, I could just write an application to the system anywhere, run it, and like an unsandboxed application on the system, run it, and boom, I'm outside the sandbox. So that's why all the sandbox application, if they write anything out to the system, those files get the quarantine flag. With the DMG, it should happen the same. The DMG got the quarantine flag, and when we mount it, the mount flag as quarantine should be set, which means anything inside the DMG is quarantined. So at this stage, without quarantine flag, it means I can drop a DMG, mount it, and run any application I want from it. There will be no pop-up, and I'm outside the sandbox. That's it. I basically used the very same exploit as the previous one because it just worked. I had to drop like an application, and that's it. Now, I noticed the behavior that, hey, I can do a sandbox escape, but why? Because if you open a DMG file that you downloaded, if you try to run an application from that, you will actually get a pop-up. That's properly quarantined. And I was like, I still open the DMG with the open command. And in fact, at that point, it is quarantined. And when I run the second mount on the device, then it's not. And I was like, why? The diskarbitrationd has a very specific check for this. There is this IO registry anti-search API, and it will search the quarantine flag on the disk. And if I check the DMG and the dev device, the flag is set. It's there. And like this IO registry search, if it returns true, then it will set the quarantine option for the mount. And I was like, there is this call, the flag is there, and it's still not set. I still reported it to Apple at this stage, and I was like, okay, I still don't know why this happens. And it turns out that we have two flows. If I run the open command or double-click the DMG file, then I actually create a disk with the DA disk create from IO media. And that's the point where it will run the IO reg search looking for the quarantine flag and set that option. If I do a disk based on the BSD name, like dev disk 5, it will not do that. And it will just call mount without the quarantine flag. So that's why the flag is essentially not set. How Apple fixed it? Basically, they moved it again down to the kernel. So during the mount operation, the quarantine kernel extension will have a check if the device has the quarantine property, and if yes, then the kernel extension will set the quarantine flag for the mount operation for every single mount operation. So that's probably the best thing they could have done. Okay, rent time. This is a pretty cool bug. It's not just a sandbox escape, but also a TCC bypass. Actually, the first one is also a TCC bypass, but I didn't know it the time I reported it. Apple fixed this in July, I think. The fix was in Sequoia Beta 2, I think, and I was like, yeah, you fixed it. Great. They released Sequoia September 16. It's patched. They tell me, I know you can talk about it because we haven't fixed it in Sonoma and Ventura. And I was like, you must be kidding. You have the fix since July, like for 2.5 months. You literally implemented in code because it's in there, and you couldn't push it to the other two versions. That's coming in the next release, so I think the next security updates, probably in October. But yeah, it's not fixed, so I'm not allowed to talk about it. So what I do, I turn to AI and started to draw some pictures. This is my favorite, actually. Yeah, I use Midjourney. I think it's pretty nice. Actually, oh, and I'm pretty sure Apple is trolling on me. They released the source code for diskarbitrationd yesterday, which contains the patch. So you can literally go diff it and see the patch, what they did. You know where to look at. You know which is the important function. To be fair, seeing the patch, it's very hard to tell what the actual problem is. I think I can still show you a video on this. So again, I have a sandbox application. It's called directory traversal. Just showing that there is nothing mounted, and I run it. I'm using the same tricks. What worked once works many times. Just the underlying problem is different. So here I mounted over the TCC directory. There were, yeah, I didn't tell, but there were no TCC permissions for terminal at the beginning, and now we have, and we also launched terminal with escaping the sandbox. I abuse the preferences directory so much that now Apple restricts it. It's TCC protected. So because I can't talk about this, I will talk about this. Although it's not diskarbitrationd D, service, but it's still related. Very simple call flow. What could go wrong? So diskarbitrationd in itself is already too complex. Now we add two more players, diskutil and storagekid. We can call diskutil that we run as us. Diskutil doesn't talk to diskarbitrationd, it talks to storagekid. Storagekid also runs as root and unsandboxed, but it doesn't do too much checks. It only does like a sandbox verification, and it doesn't do any privilege verification. Storagekid calls into diskarbitrationd, calls into mount the kernel. So here's what happens. I have a disk, a volume. I want to mount it over somewhere owned by root as the user. Call diskutil, same privileges. Call into storagekid, we get a pass. It literally doesn't check anything. So yeah, go ahead. I call into diskarbitrationd. Now the problem is the client for diskarbitrationd is storagekid who runs as root. So now the caller is root and the disk owner is root. So diskarbitrationd says, yeah, go ahead. Now everything is root. We get to the kernel, still everything is root. We are good to go. That's it, really. So we can mount over any directory which is owned by root. Here is the flow, how to actually weaponize this. Because I can mount some. I cannot mount over the cron tab directory. It's protected by TCC. I cannot mount over the pemd directory. It's protected by TCC. Periodic scripts were protected by TCC, but now they are gone. Everything cool that you can abuse is protected by TCC, except cups. I guess that's coming in the next release. You can blame me for that. But what we can do with that, we mount over the cups directory, and there is this cups-files.conf. And this is pretty nice. There are two settings. One, log file permissions, where I can literally say what permissions I want the log file be created with, and I can give it the error log location. So I will just say, okay, put it in the sudoers directory with 777. I run cupsctl. Actually, it will trigger the log, so the file will be created with 777 privileges, so I can overwrite it. Obviously, sudo will not read it because it's word writable, so it will ignore it. But because I can still change the cups files config, now I change the permissions to be 700, so it's only writable by root. And I run cupsctl again. It will change the permission on the log file. And it will put in a lot of junk in that log file, but sudo doesn't care. It will find the everyone can authenticate without a password, and it will understand that and will ignore all the other lines. We'll throw you some errors, but who cares? And then you run sudo su, and that's it. You elevate it to root without a password. This is actually pretty fast. So again, this is not a race condition. The only thing that causes it to be slow is cupsctl is a bit slow. So I'm like waiting 10 seconds between the triggers. But that's it. You can see that there are some errors by sudo that it doesn't understand the logs. But like, yeah, who cares? We are already root. To be continued. Again, the one I couldn't talk about it. And then there is another one as well. And then the storage kit. So this storage kit was fixed. I bypassed the fix, so that's also coming. And because you have this very complex workflow, if you fix one, you might screw up the other. So yeah, it's a it's a mess. Conclusion: definitely, diskarbitrationd is a service which keeps giving. It's a very profitable with the Apple Security Bounty program. And yeah, I wish I could say something smart here, but yeah, I think it's just hard, especially if you have all these complex inter-process relationships and so on. That's it. Thank you.